The author's main objective is to help students, researchers, statisticians, and textbook writers to facilitate the learning of statistics. That aim was partly achieved with the publication of the software Statistics for Beginners, which helps equip the user with the basic statistical know-how essential in making research. After more than 3 years of publication of the software Statistics for Beginners, many users have signified appreciation of its usefulness, as shown in the users' testimonies, as well as in the series of seminars that the authors conducted throughout the Philippines and by the various awards from different sectors that the authors received. The program has a pull-down menu where a user can select the necessary statistical tools. For example, the user can select Pearson-Neumann correlation to get the inference and degree of relationship between two interval or ratio scale data. The user can change the number of samples and then press the Enter key. The user can only enter data in the right cells, such as in X 2, 3, 4, 5, and 6, and in Y 3, 4, 5, 7, and 7. Pressing the Compute button will automatically show the results. The advantage of the software over the leading software on the market is that it has a procedure where the user can check how the values were obtained. For example, the square of 2 is 4, the square of 3 is 9, and the product of x and y, 2 and 3, is 6. It is separate tables where the totals are indicated, especially when there is a long list of data. Clicking the formula will show the step-by-step procedure, so the user can easily compare the results with those of the manual computation. The program has a frame which the user can move to see the data or turn off after use. The program also shows the degree of freedom and how it is computed. It also has tooltips for the meaning of variables, and on the right side of the window are other buttons. The correlation table button is used to determine the degree of relationship based from the R value. The T table button is for determining the tabulated value based from the degree of freedom. The information below the T table states that reject the null hypothesis if the computed absolute value is higher than the tabulated value. The decision button is used for determining the rejection or acceptance of the null hypothesis. The scatter plot button is for the graph of the data. The export button is used to send the data in DOS file for use of other software. Pressing the print scroll key will allow the user to lay out the graphics output to other software. The new button is used for a new set of entry, and the close button is used for other statistical tools. To use Statistics for Beginners, click at once to show the statistical tools arranged in matrix forms. On top can be found the descriptive statistical tools, and below the inferential statistical tools. Along the rows are the level of measurement, such as nominal or categorical scale values, rank or ordinal scale values, and interval or ratio scale values. Across the columns are single variables, two variables, more than two variables, correlation or regression tools. For example, if the data are counted and there are more than two variables, the user will select chi-square. After clicking the tool, a dialog box will appear where the values of rows and columns change as the user indicates the rows and columns and presses the Enter key. The user then must enter the data, then click the Compute button. Automatically, the chi-square value will appear. This table shows the step-by-step solution of individual cells. It shows also the total of all the partial values of chi-square. Clicking its row will show how the partial expected value, or E, is obtained based from the formula below the table. It also shows how the degree of freedom is computed. On the right are other buttons such as the chi table and information how the null hypothesis is accepted or rejected. The chi table indicates that the user should reject the null hypothesis if the computed value is higher than the tabulated value. The graph button shows the behavior of the graph. Although this program provides the decision button, which automatically indicates if the null hypothesis is rejected or accepted, it is highly advised that the user must first get accustomed to reading the chi-square table. This is to ensure that, in the absence of computers, the researcher or statistician can still make use of any statistic textbook, where such tables are often used. Finally, the Note button will show the requirements for chi-square. The user can now click New to start or Close to select other statistical tools. A user can use the data again and again, and with other statistical tools, he or she can make use of the sample data under the item. The user can enter the sets of data and save them for future use. For example, the user can edit or add records or delete records by double-clicking the row to delete it. The user can likewise click on the Transform button to rotate the data and adapt the presentation to the desired orientation from columns to rows and vice versa. He or she can select Activate button and then select the statistical tool. For example, the user chooses multi-regression, where he or she can double left-click on the space provided. The user can select the column letter and click the Paste button, then finally click the Compute button. If the user chooses stepwise regression, he or she has to press Best Fit button to see the best equation for the data combination. For simplicity, the user can use the Enhanced Analysis of Variance two-way, as n is equal to 5 and k is equal to 3, then press the Enter key. The user must double-click columns for the data, then click the Compute button. Clicking these buttons will enable the user to see the computation, formula, and source of variation. The source of variation includes the F computed and F critical value. It also shows no asterisk, 1 asterisk, or 2 asterisk to indicate not significant, significant for 5%, or significant for 1% respectively. This is used for classical approach of hypothesis testing. The user may also double-click the F value to get the p-value or probability value of the data. This is used for the modern approach of hypothesis testing. If ever there is a significant difference between the variables, the user may use other buttons for post hoc tests, such as two-case honest significant difference test, two-phase test, Student Newman's Cues test, Fisher's List significant test, Duncan's multiple range test, The user may also perform the other way to statistical analysis by using confidence intervals such as Bonferroni, pairwise, estimate, and others. To close the program, the user must press the close button.